All right, chapter 4 is all about quadratic functions. So this will be our third function type that we've talked about here in Algebra 2. The first one being linear function, which takes this form. Then we talked about our absolute value function, which takes this form. All right, so linear function obviously is a line. Then the absolute value function is going to take that V shape, whether pointed up or down, depending on the value of A. And in this new function, in our quadratics, they're going to take this form. Okay, so the highest exponent is going to be a squared, whereas in linear, the highest exponent is a 1. And then in absolute value, we've got an exponent of 1 on the x, but it's also inside those absolute value symbols. So anytime you see a function that has its highest order, its highest exponent as a squared, then you know you've got a quadratic. And this is going to take a parabola shape. It's that U shape. It can open up and it can open down depending on the value of A as well. So if we look over at number 1, and we want to tell whether the graph opens up or it opens down, just like in all of these other functions, we're going to be looking at the value of A to do that. So in the case of number 1 over here, we have an A value. That's the coefficient on the x squared is your A value. Actually, let me rewrite that over here, our form. And so in this case, we can see it's a -3. Because it's negative, we know that this is going to open downward. Okay, just like in all the other equations that we've done, all the other types of functions, a negative is going to mean opening downward. Then they want us to find the vertex. So the vertex in this case is going to be a maximum point. If you think about it, if we have a graph and we have a parabola shape that's opening downward, then this point up here, where it hits the line up here at y, is going to be the highest point. So we call it a maximum. And so what we're trying to find is that exact point, and that's what we would call the vertex. All right, so the formula for finding the x component, the x coordinate point for the vertex, is the opposite of b over 2a. All right, so in our case with this problem, our b value is actually 0. If you look here, we've got a -3x squared, but we don't have a coefficient with just an x to the first power. So we know that the reason for that is because our b is 0. So if we filled in the numerator with 0, 2 over a, we can go ahead and do 2 over a, which would be 2 times -3 in this case. We're going to get 0 over -6, and we know that's going to be 0. Remember, we can divide 0 by something. That's okay. We can't have 0 in the denominator. That would be undefined. So in this case, our x coordinate point is 0. Should put a 0 in there, not x. And then just like we've always done, in order to find the y, once we have x, if we're just going to take the 0, we're going to plug it back up into the original equation and calculate y. In this case, it would 0 out that first term, and we'd end up with a y of 1. So our vertex, in this case, is going to happen at the point 0, 1. That will be the maximum point, the highest point of that parabola. The last thing that we need to calculate is the axis of symmetry. That axis of symmetry is going to be the mirror, very similar to the absolute value function, that mirror that runs down through the vertex, through the center of the parabola, and then points are mirrored on either side of that axis of symmetry. So the axis of symmetry is always going to be that x coordinate point. So in this case, it's going to be, the axis of symmetry would be x equals 0. All right, and you'll see that as we do a few more, that'll make a little bit more sense. So moving down here to number 5, we're going to look at our a value, that first coefficient on the x squared, and we can see it's positive, so that lets us know that this graph is going to open upward. we're going to find the vertex. So in this case, if we're finding the vertex of a parabola that opens upward, if we're looking at that on a graph, that means that it's going to be opening like this. And so this point down here is your vertex. So this is also, the vertex that's sitting at the bottom of a parabola is called the minimum. It's going to be the furthest point down. It's going to have the lowest, the smallest, I should say, y value, value for the y coordinate point. So in order to do that, we do it the same way though, whether it opens up or down. We calculate our x coordinate first by taking the opposite of b and putting that over 2a. So in this case, our b is -5. So the opposite of b would be 5, and then 2 times a, which is 5 as well, will give us 5 over 10, and we will reduce it to 1/2. So our x coordinate point for the vertex is 1/2. And then I'll take that x, plug it back in up here for x squared and at x. All right, so let me show you that. I'll show you that over here. And this is just evaluating at 1/2, but I want to make sure that you have a review of how to square that fraction. All right, so there we have the 1/2. It's going to be placed in at both of those spots. There's an x squared and an x, so we've got to make sure we plug it in at both places. We have 5 times 1/2, which is squared. So if I do that in 2 steps, it would be 5 times 1/4, because 1/2 times 1/2 is 1/4. And then here I'm going to go ahead and multiply the 5 by the 1/2. And then I'm going to end up with this right here. All right, so then at this point, we've got 2 fractions with unlike denominators, so we've got to make the denominators match. In this case, the least common denominator would be 4. So if I make this 4, then the numerator will be 10. Oop. Okay, and so we'll end up here with 5 and 3/4, a positive 5 and 3/4. So that's our y. 5 and 3/4 would be the y on our vertex. And then last, they ask us for the axis of symmetry. So we're just going to go in, pull out that x coordinate point. That's where the mirror is going to run down through that x point. So x equals 1/2 is our axis of symmetry. And 7 through 9, we need to match the equation with the appropriate graph. So we can start out, the most obvious place to start on these is to look at the a value to see if it's negative or positive. But we can see that all of them are negative and all of the graphs open downward, which is what we would expect with the negative a's. So that's not going to help us narrow anything down. The next thing, there are a couple ways things you can do, but the next probably easiest thing to do to narrow down is to look at the y-intercept. When you have your quadratic. Okay, so here's your form again. All right, we know that a value is going to give us tell us whether it's opening up or down. Our c, the c value is going to be the y-intercept. So in y equals mx plus b, when we had a linear equation, the b told us where it crossed the y-axis. In a quadratic, the c is going to tell us where it crosses the y-axis. So we can kind of come back over here and sort of narrow down a little bit. We can see that we've got a c value here of -2. Number 8 has a c value of -2, while number 9 has a c value of +2. So we can go in and look and see that a down here is going to have a y-intercept of -2. Graph B will have a y-intercept, B will have a y-intercept of +2 up here, and C has a y-intercept again of -2. All right, so that helps us a little bit. That helps us narrow down that number 9 is most likely going to go with B. Okay, we're going to kind of check ourselves here in a minute with the axis of symmetry, but we still don't know enough about the graphs of A and C to tell which one they match with. So now we need to go in and we need to find the axis of symmetry, and that will be the last thing that we can use to narrow it down completely. If if we calculate our axis of symmetry here, remember we do it the same way. All we need to do to find axis of symmetry is find the x coordinate for the vertex, because that's the topmost point or the bottommost point. Everything else is going to mirror around that. So we just need to find that point. And again, we do it with this formula. So for number 7, the axis will be -5, and then that's 2 times a -1. So the axis for letter A is, I'm sorry, number 7 is 5/2. Okay, so I'll just write this up here. The axis for number 7 is 5/2. For number 8, the axis we'll calculate the same way, the opposite of B, which in this case is going to be a +5, and then times 2A, which will give you a -2. So the axis for this one is x of -5/2. And then we'll just double check this with our number 9 just to make sure it really does match with B. In this case, there is no B value. There's none recorded there. So there's no x term. There's an x squared term and there's a constant, but there's no x. So that means we've got a B value of 0 over some other number. It doesn't actually even matter, because in the end we're going to end up with the slope, an x coordinate of 0. So our axis in this case is 0, which if we look at B, we can see that's true. The vertex is running down, I'm sorry, the mirrored part of the graph is running down through x equals 0, so we know that we are right about B matching with number 9. We can look at, then again at A. So here we have our vertex for A. It's this topmost point right here. So our mirror is running down through that. And we can see that as we cross this x-axis, we are crossing at -2.5. So that matches with our axis of symmetry that we calculated for number 8. So we would say this one goes with the graph for A, and then as we come over here on C, here's our vertex, and then our axis is going to run down through there. As soon as it hits this x-axis, we can see it's at +2.5 this time, and so that confirms that number 7 is the equation for the graph of C. All right, coming down to 10, 11, and 12, we're going to graph the function, label the vertex, and that axis of symmetry. So starting with number 10 there, on number 10, we can see that we don't have a B value recorded. We don't have a bx. So that means that when we go to calculate our x, we're going to end up with an x of 0, because again, it takes this formula. If we've got a b that is 0, as it is in number 10, then we're going to end up with 0 over some figure here, and we get an x of 0. So our x coordinate for the vertex is 0. We can plug that x back into here and see that we're going to get a y of -3. So in this case, our vertex is going to be 0, -3. We go ahead and plot that right there. And we also know that our axis of symmetry is going to be the y axis there then. Okay, it's going to be, here's our mirror, is going to run through that x coordinate of that vertex. All right, so from here then, we all we need to do is calculate one more point. So we can go to the right or the left. I'm going to go to the right, and I'm going to calculate what my y is when my x is 1. So I will just take 1 and plug it in here, and it'll be 1 squared minus 3, which is going to give me -2. So when my x is 1, my y is going to be -2. So that will put me right here. And because this is a mirror, and it's going to have a mirrored image across, I could calculate, I could come over here and plug -1 in to the function up here and calculate out my y, but I know it's going to be a mirrored point because of the shape that these parabolas take. They're very similar to the absolute value in that regard. And so now I've got 3 points, and I might want to get another point just to make it a little bit easier to connect the dots. So I could just come over here to 2, plug 2 in at x, and say 2 squared is 4 minus 3 is 1. And and I could get another point. So that would be at x of 2, y of 1. Plot that there. If that is true, then I can come over here and I can plot this, and then I can connect all of those. And when you connect those dots together, make sure you're getting a nice curved shape on the bottom. This is not absolute value. It is not a V. So you want to get that nice curved shape. Otherwise, it's going to look like you were trying to graph an absolute value function. So number 11, let's go ahead and get our axis of symmetry and our vertex. So I'll start with the x coordinate. And we'll end up with, ooh. All right, so we're going to have an x of 1. If I plug 1 back into this equation and evaluate, I'm going to get a y of 2. So my vertex on number 11 is going to be, maybe I'll write it over here, 1, comma 2. So I'll come over and graph that. Now, we could do the same thing here where we pick another x. You know, I could pick x of 2 and plug it in here and calculate out my y. Or I can actually look at my y-intercept and go from there, because we know this is going to be our symmetry right down here through the vertex. And so we can look here and see that because my c is missing, okay, that ax squared plus bx plus c, that c is not there. Just like in y equals mx plus b, when b is not recorded, we know it's a y-intercept of 0. It's the same thing in quadratic formula. When it's missing, we know it's 0. So my y-intercept is happening at 0, which is going to put that right down there. So there I just got another point without actually having to do any evaluating. And then I can mirror that point over to here, and that gives me a third point. And then I can connect those three, trying to make as smooth of a curve as I can. It opens downward, which is what we expected from our negative 2. All right, we'll do one more. We'll start with our x. All right, so there's negative b over 2a. I'll reduce it and get that negative 3/2. All right, if I evaluate negative 3/2 back into the function, I'm going to get a y of negative 3 1/2. So I'm not going to go through the algebra, but our vertex will be this right here. So negative 1 1/2 and negative 3 1/2. So that's going to put our vertex right here. Okay. And so there's our vertex, and our axis of symmetry is going to run through that point. And we know this is going to be opening upward. So again, I could put in an x and calculate out my y and then mirror it over, or I could look right here at my c, which is 1. And I can say, okay, my y-intercept is going to happen at 1. So I'm going to put that right there. I'm going to mirror that. That's 1.5 units from the axis of symmetry. So I'm going to go 1.5 units to the left of the axis to get my third point. And then I will connect those dots with a smooth curve at the bottom. All right, and then in 22 through 24, we have a word problem. A baker has modeled the monthly operating costs for making wedding cakes by this function they've written there, where y is the total cost in dollars, and x is the number of cakes that are prepared. They want us to find the vertex and the axis of symmetry. So this is no different than the other problems we've done. We're going to find the vertex by calculating the opposite of b over 2a. So in this case, that will be a positive 12 over 2 times 1/2, that 0.5 there, which will give us a positive 1. All right, so we're going to have an x of 12, and then we'll put that back in to the function. I'll show you that. So it'll look just like this. We're just going to evaluate at x of 12 and find that when we do that, we're going to get this right here and then end up with a y of 78 in the end. So when x is 12, y is 78. This is our vertex. Our axis of symmetry then is that x coordinate. It's going to run down through x of 12. All right, so if they haven't asked us to graph this, but just to show you just real briefly, and this is not at all going to be to scale, they've told you that your y is your cost in dollars. Okay, so your y-axis is your cost in dollars. Your x-axis is the number of cakes that are made. Okay, so cost for the cakes and the number of cakes made. If we're looking at this vertex then, the vertex is happening when we have made 12 cakes and spent $78. So that means the vertex is happening right here. And if you look up at that A, it's positive. So because of that, we know it is going to be opening upward like this with that axis of symmetry running down through the 12. Okay. This point right here, then the vertex is called the minimum because it's the minimum point on the y-axis. So when they ask you what the minimum cost is, that you're answering that y right there. That y coordinate for the minimum point is 78. So the minimum cost that we can have here, according to this function, is $78. How many cakes should be prepared each month to yield the minimum cost? Well, that is your x coordinate for the minimum, okay, for this vertex. So the answer there is when the cost is at its minimum of $78, the number of cakes prepared is 12.